Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You start by confirming power and signal paths so nothing gets damaged. Connect the servo ground to your controller ground first. This common reference is why the signal works. Once done, route the servo V+ to a regulated 4.86V rail or external battery if needed, and keep leads short. Plug the servo signal wire into the designated PWM pin on your microcontroller. Make sure power wiring can supply current spikes. This prevents resets and noise when the servo moves. You now set up the control signal and verify motion. This is where timing matters. Program your microcontroller to emit a 50 Hz PWM frame and vary the pulse width between about 1 ms and 2 ms to sweep the servo. Once you have code, upload a slow sweep routine and observe travel. Adjust pulse endpoints to avoid binding. Make sure mechanical linkages are loose during initial tests so the motor isn't fighting stiction. If results are twitchy, add small delays between steps to smooth movement. You finish by mounting and validating the system under load so it performs reliably in real use. Tighten the servo to its bracket, then run the same calibration sweep with the intended linkage attached and watch for any binding or excessive current draw. Monitor supply voltage for dips. A 471,000 μF capacitor near the servo supply can stabilize spikes. If the servo jitters, first confirm a solid common ground. Then test with a different power source and reduce mechanical load until behavior is stable.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.